Good morning, everybody. I've got a bit of a challenge with this presentation because we're putting together a new website, and those of you who've battled through our registration and request system will know it isn't entirely friendly. And I promise you we've got a much more streamlined and optimized system coming. As part of that, they said, oh, it'd be really nice to get a new presentation about the university program. And the suggestion was, well, we're filming Imperial. Oh, sorry, video recording. How old-fashioned to say we're filming. And why don't we use that? And I thought, we could, but it means that I'll be presenting the program sort of in general to an unspecified audience, where I'm actually standing up in front of a specified audience. So I'm going to split it into two parts. I just want to do a little introduction which is specific to Imperial, and then forgive me, when I present the university program, I'll do it as if the world is watching, so to speak. So first of all, I have to say how nice it is to be back at Imperial College. And he's slipped out of the room right now, but as those of you who know him, the redoubtable Peter Chung is here, when we're honored to have the head of the School of Design Engineering to be attending the workshop today. And any of you who've worked with Peter will know what an inspiration he is. And our links with Imperial owe a great deal to his. So I should add his name to the thank you list. I also like to say thanks to Roy, who's here. He's come all the way from Canada to be here today. And I think we have a gentleman who's made it all the way down from Birmingham to be here as well. And I can see that Essex and Surrey made it. Who else is there? Brunel, I know, is here somewhere. So welcome to everybody. And I can see that people are getting back in the habit of in-person events, because we did something in April and it was a real struggle to get people to that, and it's getting a bit easier. And these events, in fact, we're moving off, we're going around the States, and we're also doing some events in mainland Europe shortly. So some thanks. First of all, big thank you to Danny, who I think is also, oh, there he is. What an excellent instructor, perfect clarity, knows the subject inside out, a real master of his brief. So thank you, Danny, because he has worked very hard with Sarah Harris to put all these materials together, and it's taken quite a lot of work. The organization of the event, although you didn't know it, but it's actually been done by two students, and one in particular, Yiting, who's sitting in the corner there. Most of the arrangements and so on were under her control. And when we turned up yesterday and found that there wasn't a projector and screen in the original room, I could tell that she was a little bit stressed about that, because she knew we've got people coming tomorrow. What are we going to do? So thank you for sorting things out, Yiting. With her, and just sort of getting into his swing, is Jin Yang. He is taking over from Yiting during the next month or so, and he will be with us for 13 months on a placement, because the university program, in terms of dedicated people, is just me and a student. So we're sometimes people think we must have a big team. Actually, no, it's just the two of us. Jackie Chin, who's a former student, also has given us some help on this event. He's in China right now, so you won't be seeing him today. And I want to thank the team at DigiKey, and YC Wang is their academic program manager at DigiKey. They've helped us a lot in the promotion of this event and help provide boards and other support. And DigiKey is the world's largest online distributor, and I have to say it's very useful to have them on our side. And obviously, as I mentioned, our hosts here at Imperial, we're in Munich on the 7th of September at the University of Applied Sciences in Munich, and we will be at the University of Alicante on the 20th, which I'm looking forward to. That's alongside a conference called Sartico. If you need more details, Danny's an expert on that. So just a quick bit about imagination. For those of you who don't know much about imagination, basically we're focused in 3 areas of the market. We produce designs of processors, and we're the leader in supplying GPUs for automotive applications. About half of all car dashboards have got one of our GPUs, or maybe several in them. That requires not just GPU technology in the sense of tablets or mobile phones, but also the ability to get all the approvals that are required. And gaining a position in the automotive business is very hard work. It takes years to build up with no business, and then it finally starts flowing. The great advantage is once you're in, it's very hard for anyone to get you out. So we're building a very commanding position in automotive. And I have to say, if someone had told me 20 years ago that communications in a car might depend on Ethernet, I'd have been nervous about that. You know, I can remember IBM telling us that token ring was far better than Ethernet, but look what happened to that. But would you believe the bus of choice around a car now is Ethernet, and we have a very good solution to the communication IP necessary to implement that. So big presence for us in automotive. We're well known for our position in mobile and consumer. We're used extensively in many mobile phones and a lot of tablets, and increasingly getting into low-end PCs, particularly in China. So this has been a relatively new market for us, and you'll find us in lots of televisions. I was particularly pleased. I just got a new LG 48-inch 4K OLED TV that has an Imagination GPU doing the on-screen display in it. We're making progress into data center. I mentioned getting into desktop PCs. Data center, because we've got low power parallel processors, they're finding their way into AI applications in centralized applications. Although this is a relatively new market for us. One of the things that's particularly interesting is in the gaming market, where we seem to have some particular advantages there. And this is not a market segment, but it's what ties all the things that Imagination do together, is that, you know, we've got GPU, we've got communications, we've got neural network accelerators, and most recently we've announced our first RISC-V CPU, which is a mid-range processor aimed at things like 5G hubs, helper processors, firmware processors, embedded control. And we've begun to move into the CPU area. So that's a bit about what the company is active in. The model is we design processors, people license that design from us, so we don't make and sell silicon chips. We make the designs that will be used. We're like architects. And they, having made the chip, they then sell that to the original device manufacturers. So this might be a company like Oppo or Xiaomi, and they talk to a particular chip supplier, which might be a company like Unisoc, and then they make the mobile phone based around that chip. We also have contacts with each part of that flow. And we've shipped about 11 billion pieces of our IP. This has actually gone up. I think this data is about 18 months old. We're up at over 40% market share in GPUs, and our 2021 revenues were $150 million. So we're a medium-sized company. We're headed towards 1,000 people. We're recruiting very heavily this year, a few in China, quite a lot of people in Poland and in Romania and in India, and a large number of people in the UK. And we have a hybrid working model, so people can work from wherever they are. And that is one of the key differences. We do not require people to come into our office. Major filer of patents in the UK, way beyond our size. We file, for our company size, the number of patents we file is very high. So, oh yeah, that's mobile GPU, 36%. I can see automotive here is 43%. And some of our major customers, people like MediaTek, the Taiwanese the chipset company, and Texas Instruments, Renesas, also a major customer for us. So I'm going to switch now. This is the part that we may put up on the new website as a presentation of the Imagination University program. So, the Imagination University program, what are we trying to do? Well, in particular, we want to help teachers to use our technologies in their courses. And we're building a global community. So if you look at our website, you may have noticed the navigation around the website is in English and Chinese. And that's deliberate because we want Chinese users to feel part of the same community. For the university program, we don't treat China any differently. They have access to the same materials. They're available in local languages in many different forms. And the aim is to build a genuinely global community. And there's just some pictures of some of the things here, you know, Paris, setting up a MOOC in Beijing, winning the Community Contributor Award from RISC-V, Robot Wars at Bristol University, and this actually the filming of the graphics MOOC. And our very first online course for any of our program was actually in China on a platform called Shuetang, and something like 1,500 students have already gone through that. So, our mission. We want to create an instinctive preference amongst the next generation of designers and programs to design in and use our technologies. Very simple. It's actually a soft sales activity. You know, I'm working 5 to 10 years from the point when we might generate some revenue, but I'm here for a good reason. I'm sort of the beginning of cultivating. I know who Imagination is. I've got some idea of who their products are, and I've used their tools to develop something. Because people like to use what they learn at university. So if they learn those tools at university, they'll take that preference with them. So when they arrive in their new job and the boss says, we need to find a suitable processor for this application, chances are that that new graduate will pick up something they already know, at least as a starting point. So there's a good reason to have a university program. So don't be shy for asking for support and our help. You know, this investment is driven because ultimately it'll help us grow our business. Now, obviously, there are other things that we might want from a university program, like finding talent. And I've just mentioned to you, we're going to recruit 250 people this year. That's the largest recruitment drive we've ever had. So, you know, please help us spread the word. We've got some really wonderful jobs on offer. And the university program sponsors 3 of the student organizations in the UK, one at Bristol, one at Cambridge University Engineering Society, and here at Imperial, the Imperial College Robotics Society we sponsor. And of course, we're always looking for smart ideas. And the university program doesn't fund research directly, but we do connect bright ideas with the right people in the company. So we can act as a broker for good research ideas and help you make connections. So if you've got a bright idea and you think, Imagination should be interested in this, you can use the university program as your window into our organization. Now, if we're going to help you use our technologies in the classroom, there's 4 things that we must do. Now, I've been doing this job a very long time. This is my 30th year of doing university programs. I started off at Texas Instruments. I had some time at ARM. I helped RS Components build their program. I did some work for Xilinx. I worked at Imagination when they owned MIPS, and then I came back to Imagination when they decided to do their own CPUs because they'd sold MIPS. And there's some recurring themes. And I'm hoping I'm going to get a few nods of the head as I say this. The first thing is, people say to me, Robert, what's the right hardware for a university? I say, hardware that costs less than $200. And they say, well, that's not a specification. And I said, yes, it is. It's pretty much a barrier. If it's going to cost more than $200 per workstation, it's probably too expensive. In fact, at $200, it may be too expensive. So low-cost hardware that is also robust in student hands, preferably not too small as well. There's a great advantage with these Nexus 4 DDR or Nexus A7 boards as they are now, is they're too big to hide in a pocket. Because some students are so keen on this technology that they want to take it home. And that's a good thing, but of course you don't want it disappearing from your lab. So the right price and being robust is important. The next thing is software. Oh my goodness, the problems that companies get into with software for academia. You know, various solutions I've seen, well, we're only charging $10 a license. If you've got 50 seats and you have to buy 50 licenses and license each seat, your lab manager is going to hate you. It's very inconvenient. So a license fee of any sort is a problem. Online licensing is about as sophisticated as you can get. But then other companies do perverse things. At TI, they used to have a 90-day time limit. And I lost count of the number of times students said to me, you know, it was really embarrassing because that TI software stopped working a few days or the day before our student project demo. Time limits are just a bad idea. Another form of limit was code size limit. So just as you're getting really good, the program grows a bit and it stops working. These are an absolute pain for teachers, and I'll be honest with you, I won't go anywhere near software that's like that. So every project I'm going to present to you, the software is not only free of charge, can be downloaded free of charge, but it has no time limits and no code size limits. And I'm pleased to say, for our CPU business, we're developing a new software development kit called Catapult SDK for our RISC-V CPUs. It'll also support lots of other CPUs, including RVfpga, and that will not have any silly limits in it. It'll be available free of charge to anyone who wants it, which is great because it means if the students want to carry on working at home, they can get the same software they've used in the university and carry on working at home. And that's more important now than it's ever been. You know, post-pandemic, home working, carrying on projects at home is really important. So I'm pretty passionate about that, as I think you've worked out. Support is usually a forum online. TI used to do it by email or phone calls, but we have a forum, and you'll find if you post a problem on our forum, you're likely to get an answer within 24, certainly within 48 hours. And if you have a look at the RVfpga forum, you'll find there's about 200 posts on there, and all of them have been solved. They've all got answers there. And that's because Yitting and I moderate those forums. As soon as a question comes in, we assign it to one of our authors, and we get you some answers. And of course, the great thing about the forum is your problem is probably the same one that other people have had. So often just by searching the forum, you can find the answer without having to put a fresh post. And then the final component, and this is the hardest part, is to create teaching materials that are suitable for the classroom. That means not marketing materials, but genuinely academic style materials. And all the slides that Danny's been showing you today are from the main package of RVfpga. You know, the classroom is not a marketplace. It's a place of learning. And it's a privilege if you choose to use our technology as the vehicle for your classes. What we must do, though, is be respectful in how we put those materials together so that you're comfortable using them. So that's interesting. Is that, okay. So I thought, is the bulb going? Need an edit there. So the style of these teaching materials is obviously academic. That's deliberate. And the materials are not just a set of slides. I'm amazed how many of our competitors seem to think offering a set of slides is all a teacher needs. You've seen the Getting Started guide for RVfpga is 100 and something pages, because we've tried to make sure there's everything in there you need to know to get all the pieces of software and the hardware working properly, and to know when it's working properly. What does success look like? If you've never done it before, you need that explained. So we go to a lot of trouble to make it easy for you and the lab manager to get the stuff working. Then there's all the materials needed, and the usual format is a lecture and a lab. And it's usually a semester's worth of materials. In the case of RVfpga, it's actually 2 semesters worth of materials, and there's a follow-on, which is the SOC course, which is another semester's worth. We even go as far as putting example questions on there. We've created supporting videos. This workshop will be posted online, so those that couldn't make it can catch up with it, and those that want to watch again are able to see examples of our workshops. So a huge amount of work goes into this, and we also try very hard to cover as many of the popular languages as we can, so it's accessible. Because if you're targeting undergraduates, local language is more important. At master's level, you can probably assume that just about everybody will be able to understand English, but at undergraduate level, local language is very friendly. So they're the 4 key components. And with that in mind, we've produced 3 main sets of materials. The first one we did was all about graphics, and we're on to the second version of that, the 2020 edition. It uses our GPU, and it is available in 5 languages. And there are supporting videos, everything you need online to run those. That can run on something as simple as a BeagleBone Black board, very low-cost board. Then there's the RISC-V courses, the RVfpga course, which are using a core from Western Digital called the Swerve. And that core is actually one that Imagination uses inside some of its GPUs. And the fundamental aim is to produce the most popular choice of course for understanding computer architecture. We want RVfpga to become a global standard, a favorite for all teachers to go to, because it's the most comprehensive and the best written and the most debugged set of materials that they can pick up. Because when you've got a classroom of students, the labs need to work. That is not the place where you can debug. We're up to 20 labs in versions 2, which is enough for 2 semesters worth of materials. And in fact, the challenge here for the teacher is there's more materials than they need. So which ones are you going to use? So you can customize by choosing the labs that you think are most relevant. And we're in 8 languages. And I just found out today the Portuguese version is going to be delayed to September, but we're already in 8 languages. And I've noticed a few Chinese faces around in the building, so you'll be pleased to know there's both simplified and traditional versions of this course. So we cater not just for mainland China, but for Taiwan and Singapore and parts of Malaysia as well. It has a sister course, Introduction to SoC. The logic behind this is, okay, now you've understood something about computer architecture, you've delved into the processor to get some knowledge of how it works. Now let's create a system on chip on the FPGA system and look at what's involved in actually creating a real SoC. And then the third area of activity, we have just finished the trial on this. We're using our 8XC GPU, which is, the trial was done on a Pumpkin board. I'm pleased to tell you there's a new board from Beagle called the BeagleBone AI64, which has the same GPU. And we will release these materials, after a bit more debugging, we will release these materials openly in September. And we've had a very successful trial, got really good feedback. And those materials will be released end of September. They cover the real basics of Edge AI. What's AI? What's Edge AI? And what are the 10 most popular algorithms that you might use in an Edge AI system? So really good basic stuff, again, aimed at undergraduates. And that is an area that will develop over the next 2 years. We've got a roadmap to add more advanced examples and higher performance examples. So 3 pillars: graphics, computer architecture and SoC, and Edge AI. That's where we're channeling our activities. And RVfpga, the team who's written this, were the people who originally did MIPS FPGA some years ago. So we had a practice run. So the second time around, we were able to do it even better. Danny Trevor Martinez and Sarah Harris are the 2 principal authors, and Zubair Kakakel is the author of the SoC materials. And we had a lot of success when we launched MIPS FPGA. I can tell you RVfpga has overtaken what we did with MIPS FPGA already in terms of numbers of downloads and numbers of universities adopting it. So this is becoming a global movement, and we're very proud of it. So clearly the team that help guide this are important, and I'm pleased to tell you that David Patterson himself has actually overseen the curriculum of this course. He keeps in touch with what we're doing, and in fact, he's going to do a module in the online course. We're doing a self-study course online with edX, and David will give one of those modules. So the man that invented RISC-V has not only blessed this course, but he's guided it, and that's important. And people like Roy Kravitz up at Portland State in the US and Liu Peng at Zhejiang University in China have all had inputs into these materials. So you see, it's a truly global project. And you met some of the team, obviously, with Danny here. I'm sort of the facilitator. I brought the team together. To be honest, I let the teachers make the decisions on the content. And I can see this is obviously an older slide because I put a note there saying add Russian. In fact, there is a Russian edition of this. We're in 8 languages right now. So it's something that has been developing continuously over the last 2 years. We've published a number of papers. There's quite a good one that's worth reading about the philosophy of the course that was published in the FPL proceedings. This is 18 months ago. And the experimental environment, the choice of platform, Arctic 7, in terms of the FPGA, is an FPGA we know very well. And the original Nexus 4 DDR and its later version, the Nexus A7 board, are already in a lot of universities, and they will be, and they're widely available. So that's why we picked that platform. You need a reasonably sized FPGA in order to accommodate the Swerve core. We are looking at the Swerve's little brother as a way of getting onto the Basis 3, which is a smaller, lower cost platform. And we are also looking at other FPGA platforms because we've had a lot of requests for those. If you're familiar with FPGAs, it's not that difficult actually to port this onto other platforms. But I think most teachers haven't got the time to do that. So they've been looking to us to help them through that. So we will, when we get time, we'll add support for other platforms. All right. Swerve core, it's used by Western Digital in some of their solid-state disk drives. As I mentioned, Imagination use it inside some of our GPUs. Why this core? Very simple, because when we put this course together, there were lots of RISC-V cores available, many of them free of charge on GitHub, but almost none of them were fully verified. And this is a key point, that we're talking real-world solutions here. I think it's important that the core you teach should be one that's appeared in silicon. Now, that brings some complexity with it, because this core is not the simplest, but it brings real-world. And I think that we owe it to the students to be teaching them on things which they will come across in real life. You know, if they get involved in SoC design after they graduate, this is a core they potentially could put inside their design because it's fully verified. We were talking recently about, you know, what does verification mean? It's a huge process, very costly, very time-consuming to get from the point that, yes, I've got a prototype that works, but will that work reliably in many, many different situations and be a reliable implementation when you go through all the tooling and put it in silicon? It's got to work first time. It's got to be right. So verification is the guarantee of that. So we wanted to pick a core that had been used in silicon that was fully verified, hence the choice of this one. We've also been producing a virtual version of this board. So the edX course will use a board which we've called VidBo, which is a simulation of the Nexus A7. So people that do the online course won't have to buy a board. in order to do some of the exercises. And that course is in preparation at the moment. There's some details on the course here. I'm not going to go through all of this. Okay. We've had some very important partners on this project. People like Western Digital, obviously, because we're using their core. The support of the people in the RISC-V Foundation has been really important. And support from people like Digilant and DigiKey has been very, very helpful as well. We also have some companies which in part are competitors, like Andes. They've been very helpful to us in Asia. They are a supplier of RISC-V cores. And Esperanto is an interesting company. It's one of the first where you can find lots of details about what they're doing. Some people think that RISC-V is a microcontroller-only architecture. Absolutely wrong. Completely and utterly wrong. RISC-V is permeating every level of computing. It's just you can't see the high end at the moment because all the projects are confidential. But I can assure you they're going on. Esperanto is now public. It's a data center AI chip. It has more than 1,000 RISC-V cores on one single chip. It works. Customers are working with it today. And it has the potential to become a ubiquitous data center AI chip. It's exploited the ability, you can customize instructions very easily in RISC-V. That's what it's exploited to get its performance. And Esperanto's next product, and I'm not giving away any secrets here, they're going to take that 1,000 processor design and make it a chiplet, and then they're going to shrink it onto 3 nanometer, and the next chip will have 64 chiplets on it, which is more than 64,000 RISC-V processors on one piece of silicon. So they've exploited RISC-V to enable them to create a very highly parallel processor. That's the first real public indication of just where RISC-V may go. Anyone asks you, what's RISC-V all about? We jointly with DigiKey, we produced a guide to RISC-V, written by a guy who's been involved in embedded systems for many years. It's in 4 languages. And what we're doing is looking at a little bit of the history, what makes RISC-V different, and we look at 3 implementations. The one you're working with, the Swerve, a soft core, the microcontroller implementation, in fact, using a Sci-5 core, which is on a SparkFun board, which you may know about, and also an MPU, a microprocessor implementation on a SciPed board using a Kendrite CPU. We take 3 well-known examples and look at them and how RISC-V is being used. That's available as a free download from our website. It's also a part of the academic guides on the DigiKey website. Okay. Graphics, as I mentioned, this is available. It's complete. It's in 5 languages. There is an online course version of this in Chinese. We also have videos. We had a workshop in April of this year, and those videos are available online as well. So you can see the original author presenting the Introduction to Mobile Graphics course. And you can run it on multiple platforms, but perhaps the most humble one is the BeagleBone Black board, which is about $50. I'm not going to go through the content. Okay, we've also taken the Beagle board, which is one of the earliest examples of our GPUs getting into everyday use. The original BeagleBone Black has our SGX 530, 5th generation GPU, very old GPU, but very, very widely known. What we've done is we've packaged the drivers with it because it was our first attempt at OpenCL running on this GPU. And there's a sort of self-study course that allows you to do some graphics on the board and then try out an OpenCL driver. We will do a Fun with Beagle 2 aimed at students and hobbyists, which will use that new BeagleBone, the BeagleBone AI 64, which has got what's called a Rogue class GPU. That means it runs full OpenCL. And we'll do a sort of self-study course on understanding OpenCL. And we're just discussing the content of that course at the moment. And finally, Edge AI principles and practices. As I mentioned, this is going to be released in September, end of September, initially in English. We have a roadmap for multiple versions of this. It's an area that's going to develop over the next couple of years as other platforms come along, and it really covers the basics of Edge AI. The platform, as I mentioned, is this new BeagleBone AI 64, which has just been shipped in June of 2022. And you can see some of the examples that are in here, you know, data acquisition, machine learning, and then image classification. Textbook example of Edge AI, object detections, image segmentation, speech recognition, voice control. These are the kinds of widely used algorithms, and we want to make sure that your students have the opportunity to learn the basics. The big challenge with producing materials here is that the platforms have kept changing. You know, when you're setting up a course, it's no good if every year the materials change, the software changes, and you think, I've only just set up the lab, and now I need to get different platforms. So we've been trying to find stability so that this course could at least run for 3 years before there's new things coming along. So this is just a summary of the materials that are available and which language they're in. As you can see, understanding computer architecture is in 8 languages, and in fact, I've just heard today that the Portuguese version will be ready in September of this year, September 2022. And Edge AI, we will launch the English version of that end of September. In terms of research activities, because that was a look at what we're doing on teaching, in terms of research relationships where we're developing new materials or working on particular projects, we've built some relationships all around the world. In the UK, links to Hull on graphics, and to Surrey on some 5G activities. We also have links to UPT and Timisoara, where we're doing some Edge AI activity, and in Wrocław in Poland. Something you might be able to help me with, I'm particularly keen to find someone to write about GPUs, our GPUs, and finding a suitable author to do a textbook, first of all about mobile GPUs, which hasn't really been written up that well, and then to home in on, okay, what makes the PowerVR GPU different and special. Ideally, I was trying to find an author who could do that in China, but after 2 years of searching, I've still not found the right person. GPU specialists are very, very rare. Lots of CPU people, but GPU people seem to be very scarce. So, how do you access these? Very simple. You need to make sure you've registered for the IUP, and then there's as you know, there's on the teaching resources section, there's a button marked teaching resources, and you can download, you can click on there, request. We look at each request individually. It's not an automatic approval, so please give us the most information. Registrations that have very little information and have got 2 Gmail addresses are not very helpful, to be honest. We nearly always respond to those by saying, can you give us some more information? What we'd like to know is who you are and what do you plan to do with the materials. You know, if you change your mind or you do something different, that's okay, but we're trying to get a picture of how the materials are being used. So please be generous with the info, and we will approve your download request quickly. Once you've got the download link, just a word of warning, at the moment they expire in 3 days. So if you don't download them quickly, the link then expires. We probably are going to need to have to update that on the new system because it's caught quite a lot of people out. But please do register. I think most people here should already be registered. So please make sure you're registered. We'll keep you informed, particularly if you've downloaded materials. When new materials come along, we always mail everybody to say there's a new version, we're adding these features or whatever. So we will keep in touch with you with what we hope will be really useful information. So that's the end of my presentation. I'd be very pleased to chat with anyone who's got questions. And once again, I have to say thank you very much for coming along today. Okay, thank you.